Okay, my name is Ruben Alonso. I am from Arts and Solutions. I will be hosting and chairing this paper session number 6. We have 4 different papers. The first one is AI for Sustainability in the Construction Industry, Camila Cervantes from the University of Minho. Then we have digital tools for management of new and innovative energy performance contracts, including comfort and flexibility into EBENTO, one-stop shop plan for responding to new business models. Clemens Mayer from Joanneum Research. Then the next one is Beyond the Measurables of Decarbonisation, Exploring the Agency of Circular Economies in the Pacific. Michael Davis from the University of Auckland in New Zealand. And then the final one is using low-cost sensors and a living lab approach towards the rollout of the Smart Readiness Indicator, a case study of a small European city by Niall Buckley, IES R&D. So we have around 20 minutes for each of the papers. Try to fit on 15 minutes and give a few minutes for potential questions. And that's it. I mean, if you want, we start with you, Camila.
So, hello everyone. Today I am going to present the AI for Sustainability in Construction Industry. My name is Camila. I am a research assistant in University of Minho. I am part of the Circular Via Cost Action too. So I am here for the cost action for circular economy in the built environment. So the construction industry is now development, and we want to join the AI with the AR, that is augmented reality with the artificial intelligence, to transform the project planning and the management processing of the industry in construction. So this study explores how is the integration of AI and the AR, and the core areas is the real-time visualization and the synergy between these two and the BIM that it's now development in the area of construction. So the key benefits of this study that we are developing is the improvement in decision making. AR helps the project managers, and the efficiency that it's reducing the time spent on the corrections by providing the real times. And we want to have a waste reduction to be the change in the industry of the construction, not to have a problem and we want to have the real time in the waste material on site. Now we are talking about the AR and BIM that create a digital twins, that it's the construction in the construction projects. Nowadays, all of us know, I think that almost all, how many people here are architects or in civil engineer? So probably we know a lot of this concept of BIM. So the idea is to have the AR and BIM, because BIM is a little bit kind of programming things. So I want to be this approach in AR because we are more visual in architect. I am an architect, so it's more efficiency to see these kind of things with the architecture part with the clients and the industry. So the idea is to have an impact in resource optimization that we will talk about in what is the app that we are using on. We will have energy saving with reducing rework, and we always are planning to be aligned with the SDGs that it's now in all the standards in Europe, essentially. Now we have a case of a study that it's an ARCHI program that we are using This program is based on MIM, that it's based on Revit or Archicad, that it's compatibility. So Archi use AI-based image that recognition to inspect quality, identify issues before they scale. So this is how we plan. This is an example. This is the case study that we use this model in Revit. This is a Revit. So we have all the IFC model, the programming part, and we have to upload to this app. To do this, that is a model, a real model that we can see in the phone, in the computer, in your iPad, something like that. So you can make change in this app to get back to the Revit thing. So that's the thing now. We are in this part of the case of study, though we can share this information to real estate for the people that can see the materials, the things more to show the people, not the IFC, that it's the code and the name and all the things. And after that, we have to update that information to IFC and came back to the BIM. So that's the thing now. So now we are, with this, we want to facilitate the communication between the stakeholders. The visualization in 3D models is more easy to all the people in construction and also to the client, so it can be more affordable in this time. And the algorithms that Archi has detect the defects in this area. So now we are in this part of the project, and now we want to have an update that in the last paper session that published BIM of ArcelorMittal said that it's gonna be more efficiency if you have the plugin to update to direct to the 3D model. So that is the second phase of the project now. We are developing that kind of plugin to be developed to the Revit or Archicad that it's going to be, to update this information and not to update the information, change the IFC, then change the code and be more efficient in that way. So that is the case of study, and that's it. I am in the time.
And part of my research is related to also to anchor BIM information to real world positions, so later it can be seen with augmented reality. So quite linked with that. You presented the building in a specific location in one of your slides.
Yes.
Is this anchored to a real location? So this is the specific location in which the building is going to be built?
That's the thing. You can use, for example, if I am here now, obviously, I can put in this area and I can see, but I can go to the side. I would want to do a building, I don't know, a fabric, something like that, and I can put there. So the idea is to be more flexible and not to be in the side, to be in the reality that you are construction. So that's the idea. And you can move the scale depending on your necessities, and can be like layers to all the structure, I don't know, electric ones, and all the things. So it will be more flexible. You can update the information and all see the result on site.
What is the typical workflow? With the mobile, you mark in a position, this is where I want to render this model, you scale it or you move it and you put it in the place, and this is just located for the next time you visit the same place, or the next time you have to do the same thing?
No, you can like save one position, one place, and then you can save all the things that you want, because almost in architectural ones want to put the house in some places different to the client, because we are thinking about the industry, so it's kind of different thing. But I think that for more usable to the client and the industry and the people that you work. You can see of that, and you can see the perspective and the sound and all the things that affect to the model.
I have another question. If nobody has a question, I will go with the second one. The second one, I mean, is about, you mentioned artificial intelligence approach about image analysis. Can you elaborate a little bit more? I saw this image, but...
This one?
Yeah, no, I think that is the Revit one.
Okay.
In Revit, you mentioned that you use artificial intelligence.
No, this one, Revit is a program that is kind of similar of Archicad, but the thing of AI is to do this, because you need the algorithms to do AI to do this perspective on a render. Because when you render the things, you have to do the code. But for architectural one, I have been in the side of architectural ones that I am doing and put the colors and all the things, but I am not working on the code. So when you put the code, it's gonna be more, how to say, you notice that the architectural one has all the IFC and the code and the program. So that is the idea to IA, not to do that, and I am not to go to the code and change all of that to get to the IFC. So do Automatica with a base of database that can upload with this IA to the IR.
So this is an IFC model represented?
Yeah.
Okay, thank you.
Okay.
Then we go to the second presentation. It's Clemens Mayer from Joanneum Research.
Yeah, good afternoon from my side. I'm Clemens from Joanneum Research, and I will show you today our project EBENTO. First of all, a rough overview about my presentation. So I will first talk about the objective and a short introduction to the topic. Then about our EBENTO project in general, about our EBENTO one-stop shop, the digital tools that we developed in our one-stop shop, and then I will go into details about the energy performance contracting, which is one of the central parts of our EBENTO project. There I will first outline the basic typical energy performance contract, and then our EBENTO NPCs, where we also added flexibility services and also comfort guarantees in the energy performance contract. So here's some facts that you might be aware of. The European building stock is responsible for about 36% of our CO2 emissions. Around 90% of the buildings that exist today will still be standing in 2050. Therefore, there is a strong need to decarbonize our building sector, and currently the renovation rates are too low to achieve climate neutrality, and therefore different approaches and ideas are needed. And our EBENTO project aims to support building renovation through energy performance contracting. And in our EBENTO project, this is done by creating a one-stop shop with digital tools that support performance-based building renovations. EBENTO project at a glance. The coordinator of the project is ETRA. We have 11 partners in 7 countries, 4 pilots, total budget and duration of 36 months, and at the moment we are on the half of the way of our journey. The project objectives. First of all, the main objective is to develop a one-stop shop platform for all actors that are involved in the building and renovation sector. Then the development of digital tools for the energy performance contracting management, which are the components of the one-stop shop platform. In general, the whole project always focuses on citizens, as they are the key player in energy transition. So the one-stop shop should support citizens to do renovations. And also, it should involve public institutions and energy communities by helping them to identify potential buildings for renovation. And finally, also the development of new innovative energy performance contracting business models that also include flexibility elements and comfort guarantees is a major objective of the project. The one-stop shop contains 3 modules. First of all, the building performance contracting module. This works as a logbook where energy efficiency certificates and also financial information for different contracts will be stored. So it's somehow a decision support system. Contract templates are stored, and the contract could be created in this tool. And the tool also supports the contract management and control of the energy performance contract. Then we also have the monitoring module, which supports the monitoring of the parameters of the houses, so the energy, comfort, so humidity, temperature, CO2 level. And in the project, we defined a list of KPIs that are needed to evaluate the energy performance contract. And then finally, we also have the simulation module, which consists of a physical simulation, so to calculate the energy efficiency of different measures, and also the economic simulation module, where you can calculate the profitability of a renovation measure. Yeah, here's some details about each single component. So in general, it's a unique platform with different roles for the management of energy efficiency contracts, simulation, and monitoring of the buildings. It also contains a dynamic map which shows the energy performance certificates for buildings in cities, so it helps public authorities to identify the buildings that could be renovated. We have the monitoring module, as already outlined before, which supports the monitoring of the comfort parameters and energy-related parameters of a building. And we also have the energy and comfort simulation based on the BIM model. Yeah, in general, it's a common space for citizens and companies, and the energy performance contracting management and control and definition is done in this platform. Okay, and now I want to go into detail about energy performance contracting. So maybe a quick question. Who has already heard about energy performance contracting? Okay, then I will go into deeper detail on that. So in general, it's a contractual cooperation between building owners and an ESCO, so an energy supply company. And the ESCO and the building owner define, before they are doing the renovation, they define the baseline energy consumption of the building. Then in the energy performance contract, they also define the type, the volume, and the quality and timeline of the investment and of the energy efficiency and renovation measures. And the special thing in an energy performance contract is that the energy efficiency measures are fully financed by the energy savings. So the customer has not to take the investment is done by the ESCO, and it's paid back just by the energy savings. And the ESCO guarantees the achievement of the agreed energy savings. And within our project, we also did market research in the European Union, and yeah, we found out that an initial market development has taken place in most European countries, but the current market development is static or just slowly growing. Energy supply contracting is quite similar to energy performance contracting, but there it's just focused on renewable energy production, so PV, for example. And this is much more established as the payback times is much lower there. And the main barrier for energy performance contracting is the long payback period, and therefore the long contract duration. So typically if you have deep renovation, you have payback periods of 20 to 30 years if you just want to pay back the investment just by energy costs savings. And that's the main barrier. And another barrier is the high complexity of such contracts, and therefore the availability of facilitators that support the contracting is the main driver. So countries that have established facilitators, their energy performance contracting is much more prominent. The basic energy performance contracting business model, as already described before, it's that the ESCO and the building owner define a baseline energy consumption, and they define which measures have to be undertaken. And then you can see in this chart on the right side, we have on the y-axis the energy and the operational costs, and on the x-axis the time. And before the renovation takes place, there is a certain baseline energy consumption and energy costs. And after the renovation is done, there are new reduced energy costs. And the difference between the baseline and the new reduced costs are used to pay back the investment. And after the contract duration, the customer benefits from lower energy costs. So then all savings are for the customer. And the long payback times and the contract durations are the central problem of energy performance contracting, and therefore we try to also involve additional revenues and additional savings in the energy performance contract to reduce the contract duration, to increase the profitability and reduce the contract duration. And there we defined two different topics. So first of all, the NPC enhancement with flexibility savings and revenues, and the second topic is the NPC enhancement with comfort guarantees. EBENTO's NPC with flexibilities. So the idea is that revenues from implicit and explicit flexibilities could be included in the energy performance contract to improve the profitability of the contracts. Flexibility services of buildings could be defined into different categories. So first we have the implicit flexibilities, which just means that the demand of a building is shifted to times with lower electricity prices. So you have a price signal and then you adjust your demand. This could be done if you have a PV system, so that you optimize your self-consumption rate in order to have overall lower energy costs, or if you have flexible electricity tariffs, that you adjust your demand to those times of the day where the electricity price is lower. And if you do that with an energy performance contract, then the ESCO has to manage the total building energy management system to control about the implicit flexibility savings. If the ESCO is doing that, then you can consider those savings also in the business model, and then you can shorten your contract duration. But then there are also explicit flexibilities. This means that you shift your demand based on external signals from a network operator or aggregator, and there the ESCO could act either as an aggregator or as contractual partner of an aggregator or grid operator. And of course, it's always important that you install during the renovation equipment that you could use flexibilities. So for example, if you change the heating system to a heat pump, then that's ideal, because then you can also use flexibilities later on if you shift the heat pump for the heating, according to price signals. And then the chart regarding business model looks like that. We have again the baseline energy costs. We have new reduced energy costs after the renovation, but we also have savings from implicit flexibilities. And those savings could be also used to reduce the payback time and the contract duration. And then the contract duration gets shorter. And you could also take the revenues from explicit flexibilities to pay back the investment costs, and thereby again increase the profitability and reduce the contract duration. And after the project or the end of the contract, then all savings are received by the customer, and all revenues from explicit flexibilities are received by the customer. And then we also looked at energy performance contracts with comfort guarantees. So there is a growing market demand for contracts that offer guaranteed comfort. And this means that the ESCO not only do the renovation and provides the electricity, the ESCO really guarantees comfort levels. So a guaranteed level of temperature, humidity, and the air quality to customers. And this should be part of the contract. And this means that the ESCO is responsible for the continuous monitoring, control, and maintenance of the building energy management system. And the ESCO takes the full responsibility for the delivery of the guaranteed functions. And thereby improved living and working conditions are achieved through the better control of humidity regulation and the air quality. And now the assumption behind this business model is that customers are willing to pay an additional fee for the guaranteed comfort level. So for the maintenance of this whole system, the customers are willing to pay for. And this operating fee, or this willingness to pay, is again used to pay back the investment costs. And this looks like that. So we have on top, so we have again the baseline energy consumption, we have the new reduced energy costs after energy renovations, we have the savings, but then we also have an operation fee for the guaranteed comfort levels that could be also used to pay back the investment. And then again the contract duration gets reduced. Yeah, so a quick summary. Long payback periods and contract durations are the main barrier of energy performance contracting. NPCs with flexibilities or comfort guarantees could reduce the contract duration. Our EBENTO one-stop shop supports building renovation with energy performance contracts through digital tools. So we developed the monitoring, simulation, and the contracting tool to better realize energy performance contracts. And in general, this one-stop shop should support all actors involved in building renovation. And we will test this one-stop shop and our new energy performance contracts in 4 pilots in our EBENTO project. Thanks for your attention.
Did you make a survey? It's based on, it's not yet implemented?
It's not yet implemented, right.
Okay, so how do you know or be assertive that they are willing to pay?
Yeah.
Yeah,
that's a good question. So,
we're looking for the answer too.
Yeah, okay, so at the moment we just did it based on literature research. So literature says that in general guaranteed comfort or an increased comfort compared to the situation before the renovation could lead to a positive willingness to pay. But indeed, it's very difficult to assess the height of this willingness to pay. So maybe we can align on that topic and and compare your approach.
Yes, and I'm asking this because as I am from Portugal and there we have a huge problem of energy poverty. So that's why I want to stress a little bit and to understand better what is the willingness to pay. So if you are dealing with this gap and this energy problem.
Yeah, if you have an energy poor household, it's difficult. So then you cannot charge for a higher comfort after renovation. So they anyway don't have enough to pay the running costs. Yeah. So therefore, that's especially a problem. Yeah, that's right. Thanks.
No, this is really interesting work. It's definitely, there's a lot of aggregators I'm working with at the moment, so it'd be interesting to see how this pans out. But in terms of the long-term, so the barriers I saw was a long-term payback and then just the contract duration. So how do you see, because I was trying to think, if I have a property and I'm like, build the PV and the battery, but I don't get any other than
Yeah, that's right. So of course, it's not just to pay back the investment, it's also to pay back the investment and pay the profit of the ESCA. So of course, a certain level of profit is always included. Yeah, and especially in PV, because if you just install PV and then you use the savings and the revenues from PV to pay back the investment, that's called energy supply contracting more. And there you have payback times of 10 to 15 years, and that's feasible for investors. So there it works, but with deep renovations, when you just want to pay back with the energy cost savings, yeah, and you have not to pay back, as you said, correct, you also have to pay the profit of the ESCA, then you are at 20 to 30 or even more years. And that's the problem, yeah. Yeah. Then you need incentives or flexibility revenues. Yeah. Yeah. Yeah, exactly.
We're actually working with ETRO on another project. We're developing a return on investment for tool. I don't want to make any commitments here, but it's to do with see how well your investment would be if you put PV in city scale maps like that. You can pick the roofs, put it on,
Yeah.
and see what your return on investment would be based on local economy. But I can see now why you're interested and where the market's going. Yeah, makes a lot of sense. Cool.
Yeah, thanks for your comments. Yeah.
Any other question? If not, I have a pair of questions.
Okay.
You have mentioned that one of the slides you mentioned about identifying buildings for renovation. You do this based on this financial model, or you have a multi-criteria decision tool that you use based on other metrics like energy poverty, some other indicators?
So to define the buildings which are suitable for renovation, right? Yeah, there we just have, so we have one tool in our one-stop shop platform, and this is this dynamic map. So the idea is that we have a database of the whole city which shows the energy performance certificates, and yeah, and based on that you can identify the buildings that are in need of renovation. This is one part, and the second part is the simulation module. So there it's possible to estimate the energy cost savings and the financial savings based on the measures that you undertake. Yeah.
So you can combine different tools from the platform in order
to find the best buildings that buildings are best suitable, right?
You have also mentioned a focus on the users.
Mm-hmm.
How did you involve users? Do you have some co-creation sessions, or what's the approach to link users to the project?
Yeah, exactly. So we have co-creation sessions with the users of our 4 pilots. So we had several co-creation sessions, because the special thing is that the building is partially owned by the inhabitants, and yeah, therefore we had several co-creation sessions to convince the pilots to do the renovation and also to install the monitoring equipment, because there you also have the GDPR issues, so it's somehow an interference in their privacy. Yeah, so there a lot of co-creation is needed. Yeah.
Perfect. And you have mentioned just the pilot. My last question was about this. If you had any pilot in which you are going to validate this approach, you can elaborate more about the pilots or provide some details in which countries.
Sure. Yeah, so we have 4 pilots. We have one in Valencia, Spain, which is a residential building, where we will implement, or which is already running the renovation. Then we have one pilot in Manchester, UK, which is renovated by a cooperative, so by Carbon Cube. And one pilot in Tallinn, in Estonia, also residential building, and then one pilot in Athens, also residential building. So it's all residential buildings, and yeah, so they are renovated at the moment, and monitoring equipment is installed, and yeah, so we're looking forward to test the contracts then there in the second half of the project.
Thank you. If there are not any more questions, we
you.
Okay, the next one is Michael Davis from the University of Auckland, New Zealand. So please.
Kia ora tātou, warm greetings from Māpihi. Māpihi is the Māori and Pacific Housing Research Centre. Māori being the Indigenous people of New Zealand, of course. And we're based at the University of Auckland, New Zealand. As Ruben said, my name's Michael Davis. I am of Samoan descent. I'm here to talk about relationships, so not so scientific, I'm afraid. This is a cultural perspective on circularity and decarbonisation of the building industry in our region. So I'll gesture to social and cultural systems to be leveraged to bring about necessary change. And I'll present Māpihi as an organisation positioned to enable such an endeavour. A quick overview of this presentation. I'll begin with a provocation before introducing Māpihi, and then I'll move on to larger questions focusing our research into circularity and decarbonisation and the context that that's occurring within. And I'll illustrate the point with 3 case studies, 2 in short measure, 1 in a little bit longer, and then conclude by extending an invitation. So here's my provocation to begin with. In the Pacific, the concern for circularity is embedded in the way we do things. The circulation of building materials is about supporting and sustaining social, economic and cultural connections between people and place. And it's really essential to understand that before any attempt to implement related research in our region. So it's about engagement, I suppose, if we're using the terms of our current forum. So I'll provide some context from which this position is emerging and so the potential it offers. But to do that, I need to shift our view of the planet a bit to that one. And in particular, the right-hand side of that spread is wonderful. I found an old paper atlas with these images in. Okay, so this is a representation of Moana Nui a Kiwa, or the Great Ocean of Kiwa, otherwise known as the Pacific Ocean, and it covers 1/3 of the world we share. Don't forget about us. In this forum, we might understand it as a carbon sink, which is increasingly compromised, but it is not a watery void. The Pacific is a space that holds relatively small, isolated, yet connected land masses, and an intense network of relationships between people and place that affect that connectedness. The Māori and Pacific Housing Research Centre has emerged in relation to this condition. We're based at the University of Auckland, as I said, to give you a sense of the larger picture we attend to before I come back to the specifics of circularity, or at least the questions that we're looking at. We are a university-level research centre. Our research supports Māori and Pacific whānau, or family, to live in healthy, sustainable and affordable homes. So enabling that are project partnerships with communities, NGOs, local and central government agencies and industry. The University of Auckland is, multitasking, what a challenge. The University of Auckland is recognised globally, I think, for its research. It's well recognised. Māpihi is one of only 7 research centres hosted there, and the only one dedicated to the built environment, which is really fascinating for me, having been here for the last couple of days and kind of going, where are we in relation to what you're all doing? You know, it's just really a wake up that I'll take back with me. We are directed by my colleagues, Professor Deirdre Brown, who is, I'll just use that mouse. Can you see that? There's Deirdre, and there's Karamia Muller. And we comprise over 20 senior Indigenous Māori and Pacific researchers. Our mission is to improve housing quality and supply for Māori and Pacific communities in New Zealand and the Pacific through impactful research that is supportive of individual and collective well-being, and based on Māori and Pacific protocol values and expert knowledge. We've got a work program that consists of points of focus on whenua, which is land, including land for commercial forests, hanga, which is building innovation and cost reduction, and kāinga, which in this context means improved housing quality and supply, all geared towards hauora, which is family, community and environmental well-being. And I'll come back to a version of this slide. National media has gotten hold of us and made a bit of a fuss and piqued a lot of interest. And our co-design ethos has energised a raft of stakeholders. And it's these relationships which enable Māpahi to leverage existing networks, existing social systems to affect the circulation and reuse of buildings, building materials at city, country and regional level. So that's where we're sitting. So our aim and invitation, why I'm here, is to invite you to bring research into the Pacific or to bring our research back to Europe to supercharge the network that we sit within to achieve necessary change in quicker time. So that kind of larger thing set out a little bit more detail. We've developed a larger plan which brings me here, and I bring them into this space, and they too would like you to join with us. Our housing, our priorities for 2024, although they're on the screen, I'll list them out anyway. A kind of housing intensification health nexus for Māori and Pacific people, a kind of simplified information platform to enable that, and self-sustaining Māori and Pacific housing industries, which is where I sit in particular. In relation to that earlier diagram, this is where our discussion of circularity and decarbonisation is located. And in terms of our project priorities, it's located within that self-sustaining Māori and Pacific housing industry sector. Okay, another round diagram for you, different scale. This is a diagram of migration across the Pacific that's occurred over thousands of years. Might also be understood as an aggregate of return voyaging routes between otherwise isolated closed-loop economies. And in those environments, people rely on local resources and often very limited technical and financial means. So that closed yet connected economic condition of the islands of the Pacific, including New Zealand down there on the left-hand side, has made them necessarily places of innovation. I'm just going to read this bit verbatim because I kind of think it's more useful if I do. People of the Pacific watch from afar as solutions issued from larger economies to the wicked problems of the climate crisis are linked to the development of advanced technologies entwined within extensive infrastructure. Where the centres of technological development in Europe or North America can draw on huge resources available within a truck's driving range to enact such solutions, the Pacific's small economies are distributed across a vast ocean, to state the obvious. In contrast, and as a result, innovation here emerges from an essential drive to make things simpler rather than more complicated. There's a really important distinction I need to draw. But that's a brief introduction to the context in which our research into decarbonisation and circularity is taking place, or is at least framed within. The larger questions focusing that research are how might circular economic initiatives unfolding in Europe be rescaled for the Pacific? It's part of why I'm here, of course. How might our traditional networks be exercised to affect their embedding and further innovation? And I'll introduce some of those networks in a minute. And what might we offer to a European economy in return? So, with regard to the initiatives demonstrated at this forum, how might we downscale the economic nodes from cities to islands, rescale geographical networks for extensive distances, and remodel the infrastructural means for water transport for their application in a Pacific context? So there's a big questions sort of sitting there in front of us, and we are scoping around these at the moment. In response to that question of what do we offer in return, there's kind of, there's some really innovative circular practices that might be rescaled for much larger economies, kind of pursuing that simpler approach. a lens to understand the social and cultural systems in place in the Pacific, and a network and related body of knowledge that connects to that 1/3 of our planet. That blue part. As I said earlier, concern for circularity is embedded in the way we do things. Yeah? It's in our relationships. It can be observed in the form of traditional tribute and trading networks. And in those circulated materials hold meaning that sustains social and economic relationships between people and place in our region. That's not just an historical condition. I'm going to give you 3 case studies to illustrate it. This is called, named, it's an example of a whale tuwhi tuwhi. Whale is house, tuwhi tuwhi is gathered materials. Okay? So a house of gathered materials. So the millennia-old Inasi tribute system of Tonga now brings into Tonga, for the purposes of house building, reclaimed materials sent by the Tongan diaspora living in the Pacific Rim countries. So think of the US, Australia, and especially New Zealand. So you have family in New Zealand scouring the kind of the recycling yards, filling containers and sending gear to Tonga for the purposes of house building in name. But what that does is affects the relationship. I am living in New Zealand, but I belong in Tonga, and I'm living in Tonga in the family land, but my heart is in New Zealand with my family. So there's this kind of effect of material exchange, kind of locking into, relationships in place. The question, of course, with this is how do you complete the loop so that Tonga doesn't end up being an end-of-life dump? So there's another thing just sitting right in front of us going, begging for attention. Another example, this is more to do with labour, the image, but it's but there's this, the point is that it can be leveraged to affect kind of circularity in the regions in particular. This is an image taken in the wake of Cyclone Gabrielle, which really smashed parts of New Zealand, particularly the North Island, at the end of, at the beginning of 2023. This is an image that kind of illustrates national mobilisation of New Zealand Māori building tradespeople, according to ancient tribal kin networks, in this case to repair climate-induced damage to housing, and that extended to infrastructure in tribal territories. I could have chosen any one of 1,000 of the images like this. It really gave us a hiding, Cyclone Gabrielle. But I'm going to demonstrate another kind of network through a project I was involved with colleagues at the University of Auckland. I was invited to contribute to the Italian Pavilion at the 17th International Venice Biennale. So that was the one that was supposed to be in 2020 and ended up in 2021 because of COVID. I still feel like this was about like being asked to represent Greece at the Olympics. It's a real honour. The theme of the Italian Pavilion was resilient communities, and the various exhibits showcased a wide kind of range of innovative approaches to a climate emergency. And our brief was to create a meeting and display space that demonstrated the innovative use of timber. We designed a timber pavilion, and that was accompanied by 4 benches. The pavilion was supported by a Bodo. Check it out, innovative manufacturer of micro-laminated pine timber cladding. Pine grows like a weed in our country. Google them. And also by Kāinga Ora, who is the New Zealand government's housing unit. So, among other things on that project, I had more here. I designed and built 4 benches. Each was 1.8 metres long. They were configured in the space to variously offer rest and articulate the space in and around the pavilion, and kind of invest the whole with a kind of a tactility or a luster or a glow. There's a pattern milled into the surface of that timber, and that you'll see in a bit more detail in a minute. And that was developed from photos of patterns left by receding tides in the black sands of Auckland's west coast beaches. So again, there's this kind of imprinting of material, a place on material, and relationships in there. Now, the timber for the benches had come from a demolished state house. So this is a state house from the 1940s or 50s, built out of sticks essentially. But that timber, which is the weatherboards on that house, was cut from kauri trees perhaps 500 or 1,000 years old. That's not a renewable resource. To me, it's like treasure, which is why we took so much time with it. And we were afforded this opportunity because the house burnt down. You can just see the char on the left-hand side. You can see the char on one lot and water damage on the lot on the right-hand side. And this is Josh essentially stripping it. So this material was salvaged and gifted to us by Kāinga. Again, Kāinga is the New Zealand government's housing unit, by far our country's largest residential landlord. The standing they hold in that housing market, when combined with effective governmental support, of course, enables them to bring change to the second largest housing market in the South Pacific. So there's a bit of clout that comes with it. The manner in which the timber was received, the sanctity of purpose to which it was put, has enabled a healthy relationship between institutions. So Mapihi, the Māori Pacific Housing Research Centre, now has some agency in that sizable housing market, in part because of that relationship formed through the gift of a small amount of what we collectively or inherently know to be precious material. In form and material, the benches were called waka, or traditional timber canoes or vessels, and also hollow log drums of the region. But they also honour the kind of maritime history of their Venetian hosts, and we've told that story very, very effectively, and the project has won all sorts of acclaim, and it continues to be published. Really, really, really tiny project, like a nothing kind of project, but it's had this really, really big impact on it because of the relationships it established and what those relationships are enabling. So putting this idea of the relationships or the networks first and expressing shared values through the exchange or circulation of materials, that works even between institutions. In this case, between the University of Auckland and the New Zealand Government Housing Agency. So that's where I'm kind of, I'll just leave it there and just outline the position. This way of doing things, it's key to embedding any measure or mechanism focused on change in our region. It's in this way Mapihi is positioned to leverage existing social systems, cultural networks to deliver to ideas of decarbonisation and circularity in the building industry in the Pacific. So, if you are interested in the Pacific, Mapihi is the key. We want you to be here with us. We want you to succeed in bringing necessary change. If you're looking for partners in the Pacific to help open up new markets or pathways or networks, we hold a body of knowledge that connects to that blue third of the planet. So please get in contact. Thank you for having me here. Thank you, Ruben.
Any question?
No.
Just a quick one.
Yeah, man.
You're in Auckland University.
I am.
Do you work with Dr. Timus Henning and Tom Logan and Tom Crochet? It's Dr. T. He always refers to himself as Dr. T.
No, are they engineer? Not in the architecture. I'm okay. I'm in architecture and planning. I'm an architect, but we're just But we're just about to be brought together as one big happy family. Oh, cool.
Horizon Euro project.
Oh, great.
For housing in Wellington. That was for resiliency in infrastructure. So
Good to know, Niall.
yeah. So it's but it's interesting because the idea of the project. Some partners are actually here at Sustainable Places. Is to reach out to vulnerable communities and check out how resilient their buildings are, basically, and map it out and test how they can cope with climate change, essentially. So
That's great to know. I'm going to loop out and grab and come back at them from via you. That'd be fantastic.
yeah,
It's. I mean, it's weird in these kinds of institutions, right? The silos, and that's essentially what this research centre is charged with, is kind of seeing what everybody's doing, bringing it together. So,
yeah.
Great.
Yeah, yeah. So we have a big contingency from New Zealand,
Victoria.
Wellington University, Auckland, and Wellington City Council, and then a private group called Urban Intelligence. So it's a whole group over there.
That's thank you.
Yeah, we'll probably
Good to know. Yeah. Do you want me to go back? Sure. Okay.
But the idea is to use like as urban furniture or any purpose.
How they worked in the space. I'll just go right back to the beginning. Is that okay? Oh, there.
Yes.
So there's two inside the pavilion, and there's these two outside. They were moved around constantly, just kind of to refresh the space. So yes, that was what they did. Now in the collection of the curator of the Italian pavilion, his family, Alessandro Mellis. So yeah.
Thank you.
Thank you for having me.
Okay, so the last presentation of today is Dr. Niall Buckley from IES. Yeah.
Do you need to talk into the mic?
Yeah.
All right. Yeah, so this one's interesting enough, small enough project. I won't go into too much detail. I'll keep it pretty top level just to keep some interest in it. But essentially what we have here is a new European initiative that some people might be familiar with, which is the SRI, or Smart Readiness Indicator. So we obviously have EPCs that most people are familiar with, which is energy performance certificates. The SRI is like an elaboration on that. It's bringing in smart technologies to improve or optimize the systems and buildings for the occupant. It's mainly focused towards energy, but there is other elements to it that's interesting as well, and that's obviously important for the occupant. So this is a Sustainable Energy Authority Ireland project. So it's a national project focused on the city of Limerick, which is about, give or take, 150,000 people. So it's a small city on the west coast of Ireland, on the Atlantic, or close to the Atlantic Ocean. And it's in collaboration with the university and a citizen science lab, amongst a few others that are in IoT technologies. IES is a climate tech firm that a good few people are familiar with. And then Carrig is to do with preservation of old buildings, basically. So I'm kind of going to go through the basics of it, just slide by slide, and then just look at some of the results and discuss it a bit, just our findings in general. But this is actually more of a social science project than it was anything to do with SRI or any clever technology or anything that we thought we were being clever with. So the interesting parts are the people. So just a brief overview of the SRI. This is essentially it's weighted on domains. So it's about basically seeing how smart a building is, essentially how a building can basically receive signals from or stimuli from the outside world, whether from the occupant or from the national grid or utilities. So, and it's how that building optimizes. Generally, the focus is on energy, but there's other parts in terms of indoor air quality. So basically, it's about improving the building's ability to use resources or to regulate itself towards the occupant. So Smart Lab set out to see how people would take to this in general. So the project was essentially a living lab approach, where we just had, quite literally in the middle of the city, an open door policy on one of the university buildings, where people could just walk in and look at different displays, such as just like a display like this, with all these dashboards for the city, such as energy and IAQ values for the city, and they could look at sensors and they could look at information on the SRI. So it was a interactive space where they could just come and go as they pleased, with the curators there, obviously managing the system, or managing the lab. We made some assumptions. The project, it was 2 years running. It's just finishing now. So we started off really quick, and we made a lot of assumptions, and we assumed that people cared about money and cared about energy and cared about free stuff, and we just made really bad assumptions about the public in general, because that's the kind of mentality we had going in, I guess. And so we focused on sensors that would kind of look at energy more so, and energy savings. This all kicked off around the same time as the Ukraine war, when energy prices started skyrocketing. So our bias kind of went towards people trying to save rather than anything else. The living lab approach, this is a generic how a living lab generally works. It's a multi-method approach in a real life setting, so in the middle of the city, multi-stakeholder. So we had social scientists, local civil servants, and then people like me, and in the next slide you'll see someone called Keen, who were kind of the experts, the tech experts, discussing the different elements of how the SRI works. So getting people in, basically gave out free sensors to anyone who wanted to sign up to the project. This is Keen, he was the IoT specialist who installed all the sensors. So we went with 2 basic sensors. One is an energy meter, just goes on the overall meter for household energy use or office use, wherever the meter was for the building. And then an IAQ sensor, which was essentially just measuring CO2 and other elements in the building. So I think this is, we had residential and non-residential as well. So it was just anyone who walked in. So we had like pub owners, we had a local museum. We have I don't know what you call it, like a monastery, I guess, a religious group. It was something like that. So there was all sorts of people and characters to meet. So in IES, we developed these custom dashboards to make it as simple as possible. A simple smiley face or a sad face traffic light system. Thumbs up if your energy is like under the average, thumbs down if it was going above. Just really simple stuff. So in the end, we got 59 buildings that received sensors, 35 were non-residential, 24 were residential. We actually had a social housing unit of apartments that took part, but we just isolated that data for now. Just so it's not part of these results. And over 160 sensors were installed. So obviously I discussed the SRI, so we wanted to see, first of all, how people reacted to the sensors and what their interpretation of smartness is, and then we also wanted to see what's the physical impact on your SRI. So going with the physical impact first, we're taking an archetypical building from Limerick, which is residential. They're roughly 100 years old. They're solid red brick. If you watch any British drama that's to do with living in East London or Manchester, that's the type of buildings they live in. So that's what you imagine in your head. So these buildings essentially were all 0% on an SRI score. They weren't smart. The best automation they had was a timer on their heating system to kick in when they wanted the heating to start. So when we gave them out these really clever sensors, we managed to bring it up to 3%. So still a G, doesn't really do anything. So we thought we might tick more boxes, and the way we used them with the software, we thought we could reach out more. Technically, you can push the percentage up based on fault detection, but that's heavily dependent on software and how you apply it to the sensors. So this is the use case where we go off the off the shelf sensors that are easy to install as well. So it's DIY. They don't do much in terms of improving your SRI. So we took an archetypical case again, and we hypothetically added different sensors that were moderately cheap but what we call low-cost sensors, but you would still spend up to about €1,500, which isn't that cheap to get these installed. These buildings, they use gas boilers, so fossil fuel, and you'll see the fuel breakdown in a slide or two. And so we thought, okay, can we hack the old system? That old timer, can we actually make it a bit more advanced? And can we make the hot water, domestic hot water, more advanced? And we focused on energy because the SRI gives a favorable weight to energy efficiency over indoor air quality or other features. So in this building now, hypothetically, can communicate with the grid because renewable curtailment on the grid could be pushed into the hot water tank. So the phone there, I can't point, but the top left sensor can receive a signal from the grid and say, hey, I want to take that renewable energy that's going to get curtailed. We're just going to heat the hot water tank, and then in the morning, the occupants can have a shower that's basically for free. And then with the other sensors below, that's basically taking the old valves off your radiators and putting in these new ones that will automatically shut and close based on the temperature and how they're programmed by the software, which is on your phone. And then there was a lot of liberties we took with technology, but we just basically said, in theory, you can make this house communicate with the grid, have fault detection, and have this building automated control, essentially through their cell phone or mobile phone. So but that only brought us from a G to an F. So it's really difficult without spending lots of money to really improve the SRI. So next slide. So this was some of the findings we had with the SRI. We had a lot of debates about what's smart, such as if you put smart plugs in, you just plug them in the wall. Is that making the building smart, or is that just something that the occupant owns that's smart? If they put their radiator into that, and that's how they heat their building, is that a smart radiator, or is it not? Technically, everything can be removed, but then do we include light bulbs or things that could be removed, like smart bulbs? So we had a lot of conversations around this. And we kind of settled on anything that's difficult to steal would probably be part of the house, and we could say that then it's part of the smart house. So, and yeah, so there was other things. So an F on a building from a G to an F is actually a lot of smart functionality in a lot of ways, but there's so many different areas of function. So there's like dynamic envelope where the building can actually open and close based on signals and whatnot. And we were like, you know, an F score could mean a smart heating system, or it could mean a smart envelope. So they had these different themes, and we weren't really sure, you know, is it a good way of illustrating how smart a building is by just giving it a grade? So essentially, here's the discussion. So some of our assumptions I said at the start, we thought the participants would be real misers and be like, yeah, we're all about saving money. But they were actually most interested in indoor air quality. They were really, really curious about their actual living situation. And in some cases, participants said they increased their energy bills in order to have better indoor air quality. For those who aren't familiar with the west coast of Ireland, it is very, very damp and very, very moldy. So people wanted the warmth and the dry conditions, and they were really interested to see how the interface was, how they interacted with the interface. People didn't like the dashboards because you had to access through your phone and go through a link. It wasn't really user-friendly. But the IAQ sensors, they had just a smiley face on the wall. So you were just in the kitchen, you looked over, had a sad face, so people would look and figure out why. So it was better for general population to have something that's right there. And then we had a few gray areas around the smart bulbs, smart valves, smart plugs. It's like, which one's part of the house? Which one goes with the person? So, and then just really quickly, just to get through the data, this is Ireland's current trajectory. We're basically, like every other European country and most other countries, electrifying everything and then decarbonising the grid, so everyone gets decarbonised together. So there's a big push, and we're starting to see that in the building stock. The bottom left is gas, the orange is kerosene oil, and then the blue is electric heating. So that's our current kind of breakdown for the occupants. So that's actually the people who participated in the project, but it's a statistical representation of the city as well, because that's what we see in the census. So nearly 75% of heating energy in homes in Ireland are directly fueled by fossil fuel, with only a small percentage having electricity. So we're trying to swap that to 100% electric by 2050 with heat pumps. So currently, the green is the national average for Ireland. So the top one there is non-residential, which is about 11,000 kilowatt hours per annum of consumption of electricity. And the bottom there is residential. And you can see the blue is the pilot site. So in both cases, we're going over the national average. And it's kind of sticking with the trends that we're seeing in the electrification of buildings in Ireland. This is the interesting stuff, I think, the IAQ. So generally, our IAQ sensors, we index them with a different project called Twin Air. And people are generally healthy. So there's no risk, there's no issues with mold in the sense that, well, we're not telling people this in case they sue us, but you know, we're just saying it looks pretty good. There's nothing to worry about. You know, everything's cool. But definitely take care of yourself and make sure you have a healthy home to live in. But what was interesting here is that we see that the indoor air quality degrades in the winter and then improves during the summer because people are trying to keep the heat in, so they close the windows. There's more CO2, there's more TVOCs, and then, yeah, they're just more interested in keeping thermally comfortable. So it just degrades over the winter, but improves in the summer. And the last one, very relevant for Ireland, is mold. So mold is anywhere basically where humidity goes over 50% and the temperature stays below 20 degrees. So you have a good risk of mold then. And we just took sensors from a random sample across random buildings with each room. So one's a pub, there's a few offices, there's a few open plan offices, kitchens, hallways. Every single one of them is a high risk of mold in all cases, no matter what you do, except for the first one, open plan. But it's so cold in there, we think that might just be a lobby, something else other than somewhere where someone's living. So really interesting stuff. We see it across both residential and non-residential. So this is just all the averages from all the sensors that went out. You can see they're all over 50% all the time. So yeah, so the conclusions were our assumptions first and foremost were challenged thanks to the Living Lab. When you just cut out the biases and you go straight to the ground and talk to people, you get some interesting feedback from different walks of life. Big focus on IAQ. People really just care about their health, and there's some cases, as I said, they're willing to spend the money to make sure they feel that they're healthy. The SRI, basically you can't shift that with low-cost sensors. You really do need to invest in the building to increase your SRI. We didn't impact any energy savings, or at least we couldn't record that element on the pilot site, which we thought we would, because we thought people would curtail if they saw their energy use, but they were all pretty happy. And the Living Lab, in my opinion anyway, was a brilliant avenue to actually, get some feedback and talk to people. And for me, I'm often always with experts who have opinions, but it's just great being on the ground talking to people. It makes you rethink how you talk, because when I started, I was like scientist, and I was like, all these complex words, and I'm really insecure, and I need to show how smart I am. Towards the end of it, where you're just having fun with people and you're talking about stuff that makes more sense. So yeah, so it was for me, it was a brilliant tool to use in projects, and I'd strongly encourage it if you're thinking of writing up a consortium and you want to start something where you want to impact the ground, get a Living Lab going. So obviously my email's there for questions, but my colleague who worked in the Citizen Science Lab and with University Limerick, Dr. Madeline Lies, I'd consider her one of the foremost experts now in Living Labs in both Ireland and probably in the EU. And she's just back from New York giving presentations. In the US, they're interested in setting this kind of stuff up as well. So if you want someone to give you a hand, take her email down. She'll be a great asset to any project. So, but that's it. Any questions? I'll be happy to take them. So. All good? Oh, okay.
No, you mentioned SRI. Which method are you using in order to collect the data from the users? Is the question the method A, method B, suppose? Which kind of approach are you following questionnaires?
It's a survey, so it's a survey that goes every couple of months that people are interviewed that are partaking, and they get their opinions on what they liked. And that's where we got the feedback on the sensors and the dashboards. Everyone's like, dashboard, no, but that thing, yeah, that was good. We'll do one final one in, I think, the end of October, and then it'll be a closing survey just to see if people come back, yeah.
The last question is about, I mean, you mentioned that it's difficult to increase the SRI level with low-cost sensors, but maybe this engages people in doing more smartification of their buildings or homes. So maybe it's the entry point, I mean, to do a further activities.
Absolutely, yeah, no, and that's probably not fair of me to say that it didn't have much of an impact, because it got people interested, and if they're interested, then, as you say, that will spawn more activity, and you have to start somewhere. Just in principle, I guess the point we were trying to make was that it's very difficult to change the grade, and people want to see the grade change, and so maybe there'd be a way of rewarding people for at least starting, because even just to start, it would be, and we did costs, and for a lot of the buildings, you're talking tens of thousands just to get it going, and that's, you know, the new buildings definitely have a smart SRI, they do, but, you know, for people who want to get on that bandwagon, something maybe, yeah, but still all open, more questions than answers, I guess, so yeah.
Thank you.
Yeah, perfect, thanks very much.
Well, I think that we can close the session now. We are, well, 5 minutes in advance, but it's fine. It has been a very interesting session with 4 presenters. Thank you to all of the people presenting and all the participants in the session. And, well, I mean, from my side, coming from also a different field, which is more related to from software engineering, I learned a few interesting points. So also thank you from my side. And that's all. I mean, see you probably next year in the next Sustainable Places with another paper session, because I think that this is the last one for these Sustainable Places. Thank you all.